Data is a king in today's modern world of social media, which receives a massive amount of data every day. Working with these high-dimensional datasets can be difficult for a data analyst. Most well-known companies such as Netflix, Amazon, Google, Facebook, and many others deals with a large amount of data and use a principal component analysis technique to analyze it and to extract the meaningful insights. PCA is the most commonly used data analysis techniques in various industries. On that note, welcome to Simplilearn YouTube channel, and today we are here with a fantastic video on principal component analysis using Matlab, which will help you to analyze any datasets in Matlab. Before we begin, are you aiming to get certified as a data analyst and want to build your career in data analytics? In that case, you can check the Data Analyst Certification course by Simplilearn, which will open the door for the best career opportunities. To find the details about the Data Analyst Certification course, check the link below in the description box. It could be an ideal solution to help you build your career in the right direction, and we have a special discount offer for a YouTube member. To avail the deal, use the coupon code YTBE15. And if you haven't subscribed yet, please subscribe to our Simplilearn YouTube channel and hit the bell icon to never miss an update from us. Before we get started, here is a question for you. In Matlab, which command is used to add a text label to the x-axis? Let me know the answer in the comment section below. Now let's have a brief on agenda for today's session. First, we will understand what is PCA. Then we will move to why it is used. After that, we will understand what are the benefits of PCA. At last, we will see the implementation of PCA for different datasets. Now let's try to understand what exactly PCA is. PCA is a tool for identifying the main axis of variance within a dataset and enabling data exploration to understand the key variables in the data and identify outliers. In simple words, PCA is a process to find outliers and the key variables in a datasets. Now we have got an idea about what PCA is. Now let's learn why it is used. PCA is a base of multivariate data analysis using a projection method. PCA is the most commonly used to represent a multivariate data table as a similar set of variables in order to observe trends, jumps, clusters, and outliers. For example, we all are familiar with Netflix. In Netflix, we have varieties of categories and numerous of people with their own choice of category. But how will they classify the number of people in a different category or in a particular category? Here comes PCA. Using PCA, we can calculate the number of categories and the people who are in that particular categories. Assume there are 750 people with the 15 categories, and we can classify the number of people in a particular category. For example, a category 1 as a 50 people, category 2 as a 30 people, category 3 as a 40 people. Like that, 750 people will be classified within the 15 categories. Till now, we got an idea about why PCA is used. Now, let's have a look at what are the benefits of PCA. PCA can help us to improve the performance at a low rate cost of model accuracy. It includes the reduction of noise in the data, feature selection, and the ability to produce an independent output, uncorrelated data features. Furthermore, PCA enables us to visualize the data and verify clustering or classifying the algorithms, and helps in improve the algorithm run rate, improve the classification accuracy, and visualization. Till now we saw what is PCA, why it is used, and some of the benefits of PCA. Now let's see implementing PCA for different datasets. We are implementing PCA for 3 different datasets. For example, implementation of PCA by creating our own dataset in Matlab. And next we will implement PCA for the iris dataset. And at last we will implement a PCA for digit dataset. Now let's see all this implementation in the platform. As you can see, we are inside the platform Matlab. First, we will implement PCA by creating our own datasets. For do that, we have to generate a data points using a random function. I'll take a variable as data and I'll create a random integer values of 1000 into 2. As you can see in the workspace, this will create a 1000 cross 2 matrix. Now we will just plot this matrix using a function called scatter, and we'll plot the data with the first column of Z, first column of data with the second column of data. We have to close 3 brackets and just press enter. As we can see, we have got a graph of our data with the first column of our data to the second column of our data. It's a scatter plot. We have so many datas in our figure. Now just quickly go back to our command window. Now we will find the variance of our data using a variable var of our data with respect to the first column, and the variance is 1.0133. Now similarly we'll do the same for our second column, and we have got the value which is almost equal to 1. Generally the variance of any data will be equal to 1. Now what we'll do, we need a more differences in our data. To do that, we'll multiply our data with another matrix with the same number of rows and columns. For that, I'll take a variable a is equal to, which is of random numbers of 2 cross 2. As we can see, we have a variable a which is of random numbers and which is a 2 cross 2 matrix. And now I'll multiply this with our data using a variable x is equal to data into our a. And we have got our x. Now we have got the more differences data which have the more differences of 1000 into 2 cross matrix. Now we have to find a PCA for this matrix. Before finding PCA, we have to find the covalence matrix and the eigenvalues of that covalence matrix. For that, we will find a covalence matrix of our matrix of our data which is of 1000 into 2. For that, I'll take a variable equals. We have a variable called cov which will give the covalence matrix of the particular input you did. I want a covalence matrix of our data and I'll just press enter. The covalence matrix of our data is almost equal to 1. Now the same way I'll find the eigenvalues and eigenvectors. For that I will give eigenvalue for, I'll just want to give it in a square brackets, eigenvector for VE, and I'll give eigenvalues for VA, which is equal to, we'll use a keyword called eig of our covalence matrix. We have got the eigenvalues and eigenvectors of our covalence matrix. Now we have to find the transforming vector of our largest eigenvector. Our largest eigenvector with corresponding to eigenvalue is 0.3524. Now we will find the transforming vector for our largest eigenvector. But I'll use a variable called u is equal to, I need the eigenvector, that is, I'll say VE of entire row with respect to our second column, because the highest value is of our second column. I'll just press enter, and we have got our transforming vector of our highest eigenvalue. Now we will find our first principal component. Before finding, let me just clear this screen. To find our first principal component, I'll multiply my x in with my transforming vector and assign to a variable. That is, z is equal to x into u. I have got my first principal component, that is z, which is of 1000 into 1 matrix. Now I'll just find the variance of my z, that is var a of z which is equal to 0.59, and quickly I'll find the variance of my x with the respect to the first column, and it is almost 0.3, and I'll just find out the variance of my second column of x, which is equal to 0.938. Now let's find the PCA. To find the PCA, we have to decode the code. To decode the code, we have to multiply this, our z, into a transforming vector. Now we will multiply and we will decode the code to get and projection values. But we know we have 1000 cross 1, which is our z value, and our view is 2 cross 1. To multiply, we should have a same number of columns. So what we will do is we will take a variable y is equal to z into u transpose. You can see when we transpose our u, the 2 cross 1 matrix will be converted into 1 cross 2, which can be easily multiplied. Now let's plot this x and y together using a scatter plot. For that I am taking one more figure. And I'll use scatter of x with respect to the first column, scatter of x with respect to the second column, and I'll just say yeah, just the scatter spelling was wrong, sorry. Now we will just label our graph by saying x label. To label our x-axis and y-axis, we can use the function called x label. I'll label the first one as PC1, and same as I'll use this y label and give it into PC2. We have labeled our x label, y label, and I'll give the title for our graph, that is PCA. Within the quotes we have to give PCA plot, and I'll just close the bracket and end with the semicolon, enter. Now we have the scatter plot with our x label, y label, and title. I'll just say hold on and we'll plot the y now. Scatter of y with respect to the first column and y with respect to the second column, and the semicolon, enter. Now we have plotted both x and y in a different figure. This is our principal component analysis plot, and this is our PCA line for our dataset. Like this, you can find PCA for creating a own dataset in Matlab. Now let's see how to create or how to analyze PCA for a iris dataset. To start with iris dataset, first see the document of our iris dataset. As we can see, this is our iris dataset doc, which has all the information about the dataset. Dataset contains sepals length in centimeter, petals length in centimeters, and to load dataset we need a two variable, that is one is for input, one is for output. All the information about the dataset will be present in the doc. And now we came to know about all the data, what are the dataset contains and how to load. As we know, to load we need a two variables. I'll take a variable for input, I'll take it as input and output as output, and I'll read the data set as iris data set. As you can see, iris data set is loaded and our input is 4 into 150 cross matrix and our output is 3 into 150 cross matrix. Now we will transpose our input and output matrix because we have 4 cross 150. We need 150 cross 4 matrix to perform our PCA. For that, I'll just do input is equal to input and same as I'll do it for output. We are just transforming our input and output. Output is equal to output transpose. As you can see, our input and output has been transposed into 150 into 4 and 150 into 3 matrix. If you can see, our output is in the vector form. Now we have to convert this vector form into an index form. To do that, I'll say vector to index of our output transpose bracket close and enter. See, our vector form which has then the value which has been in the vector form which is converted into our index form. Now what we will do is, now we will just assign this conversion into our output. Output of, I'll just say output is equal to vector to index of output transform of whole transform. As we can see, we will get this value which is, now our output is 150 into 1 matrix. Now we will just print our input and output in the form of, sorry, I just made a mistake in my output spelling. Now we can see this 4 rows is an input and the last one is an output row. As we can see, 5, as we know, iris is a data set of flowers and its characters, and which is a 5 character, 3, 4, 1 and 0.2. Then the output is 1. Like that, this 4 rows contains the input and the last row is the output. Now we have the certain amount of 150 inputs and outputs. Now we will find the PCA. To find PCA, I am using the keyword called PCA of input. We have got the PCA of our input, which is a matrix, and the matrix is a 4 cross 4 matrix. Now I can also find a PCA of our input. I don't want this 4 cross 4 matrix. I'll just specify this new number of components, that how many components I have want in my principal component analysis, that is PCA is equal to inputs. You can assign to a variable, otherwise you can also do it like components close, and you should specify the number. If I specify 2, I want 2 components. If I specify 3, I want 3 components. I want 2 components, so I am specifying it as 2, and then when we press enter, we'll get a 2. We can see now we have got our PCA into 2 components. If you want, we can display that by removing the semicolon. We can see PCA of our input with respect to our 2 components that we have got. We have got only 2 components. Now we will find the transformation vector and we will find the PCA of our input of these 2 components. To do that, I'll assign this to a variable u and z. Close the square bracket and equals. Now this is a transformation vector, and our first PCA, we are finding our first PCA of our iris data set to our input data of two components. I'll just end with a semicolon and enter. Now we have got our U, which is of 4 cross 2, and we have got our Z, which is of 105, that is 150 into 2 cross matrix. Now what we'll do, we'll plot this and we'll get our graph. To do that, I am using a scatter plot for our variable Z with respect to the first row and with the Z with respect to the second row, and I have to close two semicolons and just enter. We got a figure with three different, we have an iris data set of three different flowers, that is the characteristics of one flower, characteristics of second flower, and characteristics of third flower. We'll just make it, we'll just go back to the command window, and we will take one more figure where I'll again scatter plot Z. Here I'll mention the plot should be of 20 size with respect to the output and should be of filled, and at the end I'll just enter. And now I'll also give the color map, that is color map with respect to, I'll give it as with the double quotes or single quotes jet. I'll give a color map as jet and close and enter. Now I'll just give the label, that is Y label, and X label, that is X label will be my input, and I've not close the quotes, sorry, my X label will be input, and similarly we do it for Y label, it will be output, and press enter. We'll also give title for our graph title, which is equal to, I'll just give it as PCA plot and close the code and semicolon, enter. Let's go back to our figure. This is our figure which have been filled colors. This is a characteristics of one flower, characteristics of second flower, characteristics of third flower. As we can see in the flower 1 and the flower 2 have some similar characters, but the flower 1 does not have any single character which are similar to flower 2 and flower 3. This is our PCA for iris data set. Now let's see the PCA, that is a principal component analysis for digit data set. To perform PCA on digits, you have to load the digit data set into a current folder. To perform PCA any dataset which is not present in the Matlab software, you have to import the dataset. To do that, you have to go to the home button. In home button, you can see there is an option called import data. Using this, you can import your data and it will be available in your current folder. When you import your data, it will automatically come to a current folder which you are working. After that, as you can see, I have already imported my digit data set into my current folder. I'll just read the data into read table of the dataset name, that is digit. Automatically it will show, and with a semicolon and enter. As you see, our data has a 1797 into 65 rows and columns. It is a matrix of 1799 cross 65 matrix. As you saw, we have read our data in the form of table. But to perform PCA, we want our data to be in the form of array or the matrix. So to convert a table data into a matrix or a array, I'll use data is equal to table to array of data. Now our data is converted into an array. As you can see, this is our data of 1767 into 65, which is converted into an array. Now I'll take a variable x is equal to data of all the rows with respect to first column till end of last but not the one column, and enter. We have deleted the last row of our column as we need 767 into 64 matrix. To do that, I just removed the last column of our matrix, converted into a 64 column. Now I'll just assign y is equal to data from starting to end, and end with a semicolon. Our y is a single row of our last data, that is 171 into a last column, only a one column. Now what I'll do, I'll just display my x with respect to the first row and the entire column, and enter. As you can see, we have column 1 with 23 rows, 24 columns with 646 and 47 columns with 64 rows. Now what we'll do, we'll just reshape this data using a function called reshape it our x with respect to the first row and all the columns to a 8 cross 8. 8 cross 8 is a size of our matrix that we are reshaping. You can see we have replaced into an 8 cross 8 matrix of our x. What we'll do, we'll again divide this by 16 and end with a semicolon. Now we will display this image. Our dataset is a digit dataset has a dataset of images. So what we'll do, we'll try to display that using a function called I am show of x with the respect to first row of all column, and which is we have divided into 8 cross 8, and the size which is divided into a 16 and end with the bracket, and I'll just check if all the bracket are closed. Now just press enter and we'll get a figure. Just let's go back to the figure, and this is a figure on our data set which can't be visible. So what we'll do, we'll just again go back to our command window and we'll just find the PCA. Now to find the PCA, we need a transform vector and a PCA. For that I'm using u and z variable which will be assigned to a PCA, that is using PCA variable, and I am using x with quotes. I need numerical components only to close and close the brackets. Now we have got our transforming vector and our first PCA. Now I will again plot using a different figure function. I'll take one more figure. I'll use a scatter plot for the variable z with respect to the all the rows and the first column. Same as the z of all the rows to the second column, and I want my bullet size to be 25, and with respect to the y, and I need the scatter plot to be filled, and I'll just close the bracket and enter. Now let's give the color map as jet, and also define a color bar. Let's see the figure. As you can see, this is our output which has been scattered. This is a 1179 into or converted into a two-dimensional matrix. Now let's go back to our this and just execute the color bar. After color bar, you can see that our data and the color bar with respect to the data which has been scattered. But finding the particular value of a particular point is very difficult in this scatter plot. So what we'll do, we'll just convert this into a line graph. For that, I'll just find the C is equal to covalence matrix of our variable, that is our data x, and I'll just find the E is equal to sort the eigenvalue of my covalence matrix, that is C, and in the order of descending. The descend keyword will arrange this value in the order of the descending, and then I'll sum all the value of E using the keyword called sum. After that, we will do the cumulative sum of our E, which is the sorting of eigenvalues with respect to C in the descending order. Then again, what I'll do, I'll take one more figure. Now I'll plot this in the line graph. For that, I'm using a plot. I'm just plotting using a plot function to plot a simple graph to our cumulative sum of E versus divided by a sum of E. And I'll just close two brackets and enter. In figure, you can see we have got this output. We have got this line where we can find out the particular x and the y value of points easily. We can find when compared to this scatter graph. In scatter graph, using this color bar, finding PCA is a bit difficult. So we have just plotted this graph, which is very easy to find the x and y values of our PCA. With this, we have reached the end of this session. Today, we have learned what is PCA, some of the benefits of PCA, and we have implemented PCA for the 3 different datasets. Please share this video with your friends and family. For more such videos, please visit our Simplilearn YouTube channel. For any queries regarding this topic, mention it in the comment section. Thank you. Keep watching.